Hi, and welcome to week 7 of our 30-week countdown for Leaving Cert Ordinary Level Maths from TheMathsTutor.ie. So this week we're going to be looking at some more area and volume, and we have 2 videos for everyone to watch. So remember, there's loads of videos for all the full members, and they're there on the TheMathsTutor.ie website. So we've picked a couple of those videos for everyone to watch. So one of them is on the trapezoidal rule. And we're going to be looking at a question on the trapezoidal rule today, but just a little bit more work there on the trapezoidal rule. And the second one is another question from the papers. So it's from the 2016 paper 2, question 7. So there's a video doing out the answers to that question on the atomium. So that's there for everyone to watch. So you might want to check out those videos after this lesson. So today we're going to start with a little bit more work on area and volume. And the first thing we're going to look at is this trapezoidal rule. So where we use this trapezoidal rule is when we have a shape like this. So this is from 2021 paper 2, question 8. And the question says the diagram on the right shows the plan of a lake. The line segment PQ represents the distance from the pier P to the far side of the lake. At equal intervals of 10 meters along this line, perpendicular measures are made to the sides of the lake as shown. So there's a few things that we need to have to be able to use the trapezoidal rule. So the trapezoidal rule is used to estimate areas of irregular shapes. So this definitely isn't a circle, it's not a rectangle, it's not a parallelogram. So I don't have a definite formula in the tables to work out each of these shapes. So this is something that is an irregular shape. And when we have an irregular shape, to be able to use the trapezoidal rule, we're going to need to have a line that goes from the widest part. So it's going to go across the widest part like this. So this is the line here that's joining the point P to Q. And we're going to divide it up into equal segments. So each of these segments here are going to be 10 meters. Okay, so each of these here have to be equal segments. And when it's divided up, then we draw perpendicular lines that go from one end to the other. So it's going to go from one side to the other, perpendicular to that red line. So making a right angle with that red line, and we're going to measure those lengths. And once we do that piece of work, we're going to be able to use the trapezoidal rule, and we're going to be able to estimate the surface area or the area. So remember, the area is how much space something covers. And you'll notice that this uses the word estimate. So this is going to be an approximate answer. So it's not a very accurate answer, or not completely accurate. It's going to be an approximate answer for working out an area. And again, because it's area, we're going to keep an eye on our units. We're going to get meters squared as an answer because all of our measurements here are in meters. So to be able to use the trapezoidal rule, the first thing we're going to have to do with it is get the actual rule. So the rule is going to be in our tables. So we have our tables here, and this is page 12 of our tables, has the trapezoidal rule. So they've given a picture of an irregular shape, and then they've given us the formula for the trapezoidal rule. So the trapezoidal rule, it says the area is approximately equal to. So it doesn't have an equals. It has these kind of little wiggly lines here telling us that it's approximately equal to. So we use this to estimate. And then it gives us a formula that says h over 2, and then we open a bracket and it says y1 plus yn plus 2 times y2 plus y3 plus y4 plus ... plus yn minus 1. Okay, so there's a couple of things we need to be able to figure out. What are the different things that are going to go into this rule? So the h here, I can see in the diagram that they give me in the tables, that's the distance that that line was divided into. So we said every 10 meters in our question, we're going to be drawing these perpendicular lines. So in the tables, it gives me this clue here. We see that they're marking out those distances along this straight line. So along the straight line, we're going to be splitting it up into all these different segments. So that's what our h is going to be. And then it says y1 plus yn. So when I look at the picture, I can see that y1 is the first line that they have. So this is our y1. And yn is the last line that we have. So when it says y1 plus yn, we're meaning this is the distance or the length of the first piece, and this is the length of the last piece. And then the rest of it says plus 2 times y2 plus y3 plus y4. And the reason why they don't say what to finish on, so here they say yn minus 1, is it depends on the question. So it depends on how many lines you have drawn. You might have 5 lines, you might have 10 lines. So each question will be different. What it means is this is 2 times all the other lengths. So these are all the other lengths. And we're going to add them together and multiply by 2. So when we want to look at this question to estimate the surface area of this lake, we're going to be using this formula here on our trapezoidal rule from page 12 of our tables. And we'll start by writing out that formula. So we're going to use the trapezoidal rule to estimate the area. So I'm going to say area is approximately equal to h over 2 times y1 plus yn plus 2 times all the other lengths. So y2 plus y3 plus y4 plus ... plus yn minus 1. So the n minus 1 just means the second last. So n is any number. So we don't know how many we're going to have. So n minus 1 is just the second last one. So when we look at our specific question here, I'm going to identify what they are in the diagram before I start filling them into the formula. So we've already circled that our h here was 10 because we said that was each of our distances between those parallel lines going up and down, which are perpendicular to the red line going across. So we're going to have h is equal to 10. We then want to know what the length of the first line is and the length of the last line. So the first line I can see fairly clearly is this line here, which is a distance of 10 meters. The last line is a little bit harder. So a lot of people would take this line and say that's the last line that's drawn in. But if I do that, I'm not counting any of this area here, and I want all the area to be included. So what we actually take as the last line is the very end of the line that's going across our shape, which is at the point Q here. Now, there's no line going up and down. So that's showing me that my last measurement here is going to be 0. So yn, or my last measurement, is 0. And my first over here was this 10. And then I want all my other ones. Now you can add them together or you can write them down separately. That's absolutely fine. And what I mean by that is that we can see that in the second line, we have a 20 plus a 20. So my total distance is 40. In my third line, I have a 10 plus 20. So that's a 30. And I can keep doing that and adding across. So these green lines here are going to be my others, and we're going to add all of those together. And you can either add them together before you start. So some people like to say 20 and 20 is 40, and 10 and 20 is 30, and 30 is 20 is 50, and 30 and 10 is 40, and 20 and 20 is 40. And some people like to leave them separate and just add in 20 plus 20 plus 10 plus 20. And that's completely up to you when you're doing your workings. But now that we've identified everything for our formula, we can start to fill in. So the area is going to be approximately equal to, h was 10, so that was our distance between all of our lines, times the first, which is 10 meters, plus the last, which is 0, plus 2 times all of the others. So 40 plus 30 plus 50 plus 40 plus 40. And just to remember that the last here is 0. So this piece of our formula is just asking for the second last. So we just keep going until we get to the second last measurement. So all the green lines in that diagram there. This then is going to be using our calculator. So now we're going to use our calculator to work this out. So we're going to say, putting that into the calculator, we get the area is approximately equal to 10 over 2 times 10 plus 0 plus 2 times 200, which will be approximately 10 over 2 times 10 plus 400, which will be approximately 5 times 410, and that gives me 2,050 meters squared. So my area here is estimated to be 2,050 meters squared. So I just make sure I go back and put in my units, which are meters squared, because we're dealing with an area. So we're going to have squared. That's the first part, and that's using my trapezoidal rule, and that's really important. So like we said, there's another video there that will help you go back over the trapezoidal rule, and that's there for everyone to have a look at. The second part of this question then says, if the lake is on average 8 meters deep, estimate the volume of water in the lake. So I don't have a picture of the depth of this lake. This is like a photo taken from the top, like a drone or a helicopter or something is flying over, and this is the shape of the lake down below. And then that lake is going to be dug into the ground, and we're going to have a depth to it. So the area is what we worked out in the first part. And we got that that was approximately 2,050 meters squared. And now we're being asked, well, what is the volume of water in the lake going to be? So the volume is always going to be how much space something takes up. So it's always going to be the area multiplied by the height or the depth. So in this case, we have our area. So our volume is going to be our area, which was 2,050 meters squared, multiplied by the average depth of 8. So we're going to be saying our volume is approximately equal to, and I'll just multiply those on my calculator to get 16400, so 16,400. And now I just have to keep an eye on my units. So my units for volume are always going to be meters cubed. So that's our first question, and it's just a piece of using the trapezoidal rule to work out an area, and then when I have an area, to use that area to work out a volume. The second part of that question then gives us more regular shapes. So our lake there was an irregular shape. Now we have more regular shapes. So these are formulas that we are going to be able to find, our shapes that we are going to be able to find formulas for in our formula and tables booklet. So part B, part 1 says calculate the volume in centimeters cubed. So it's giving me my units, so in centimeters cubed, of a hemisphere of radius 21 centimeters. So I'm going to mark what shape it is. So it's a hemisphere here. And then it says give your answer in terms of pi. So whenever I see this in terms of means that I'm going to have that in my answer. So if it says in terms of pi, that means my answer will have a pi in it. So we're going to go and look for a formula for the volume of a hemisphere. So when I go to my tables again, so when we open our tables, and we'll just move over to see them here, this is the part of my tables that I'm going to be looking at. So this is page 10 of my tables, and I see that on page 10, I have formulas for a cylinder, for a cone, and for a sphere. The shape that we were given in this question was a hemisphere. So a hemisphere is half of a sphere. And there are no formulas given in my tables for a hemisphere. What we need to do is take the formulas for a sphere and we multiply them by a half. Now we're going to be looking at the volume. So it is just going to be a half of the volume. If it's going to be the area, this area here where it says A for our sphere is the surface areas of the piece on the outside. So if we were to cut this in half, we would just be getting the outside. And just to bear that in mind, because sometimes they'll ask a question about the total surface area, and I'd have to include the circle on top. So if you can picture cutting that sphere in half, you'll see that you'll get a circle exposed on the top as well. So we've no formula for our hemisphere, but we're going to use our formula for our sphere. And it tells me that the volume of this sphere, of any sphere, is going to be 4/3 pi r cubed. So we're going to go back to our question and we're going to start with writing out our formula. So our formula says the volume of a hemisphere. So I'm going to say the volume is going to be half of the volume of a sphere. So a half multiplied by 4/3 pi r cubed. Okay, so I want 4/3 pi r cubed, And I want my answer in terms of pi. So when I want my answer in terms of pi, I'm going to leave pi in my answer. So I'm going to use the pi button on my calculator. So I'm going to fill in. So in this case, we have a half multiplied by 4/3, multiplied by the pi button on my calculator, multiplied by the radius cubed. And when I look at the diagram, I can see that the radius of this hemisphere is 21, and it tells me that in writing here in the question as well. So multiplied by 21 cubed. And that can go into my calculator, and my calculator will give me my answer in terms of pi. So I'm going to write 6174 pi. And then don't forget your units. So pi are not your units. Pi is a number. So when I want to put in my units, it says in centimeters cubed. So volume is always cubed, and our radius was given to us in centimeters. So it's going to be 6,174 pi centimeters cubed. So that allowed us to work out the volume of the hemisphere. So we weren't able to find that formula directly, but we had the volume of a sphere, and it's just going to be multiply that by a half. The second part of part B says a buoy on the lake is in the shape of a hemisphere of radius 21 centimeters surmounted by a cone. Okay, so we see this unusual word, surmounted by a cone. That looks a bit complicated, but when I look at the picture down here, I can see that that's just that I have a hemisphere with a cone on top of it. The volume of the cone is equal to the volume of the hemisphere. Find h, the total height of this buoy. So I'm looking for the total height of it. So we're going to work with what information we were given here. So what information we were given here, this is the most important line. The volume of the cone is equal to the volume of the hemisphere. It tells me it's a hemisphere of radius 21. That's the part that we worked out in B part 1, because this was a hemisphere of radius 21. So I know that the volume of this hemisphere down here, the bottom part of this shape, is the volume that we've worked out in part A. And I also am told that the volume of the cone is equal to the volume of the hemisphere. So I'm going to go to my tables again, same page, and I'm going to look at my formula for a cone. So I look at my formulas for a cone, and it says my volume is going to be 1/3 pi r squared h. So that's the formula that I'm going to be using for my volume of a cone on page 10 of my Formula and Tables booklet. V is equal to 1/3 pi r squared h. And as always, I'm going to write out my formula first. So I'm going to say the volume of the cone is 1/3 pi r squared h. And I know that it's equal to my answer that I got up here, so I'm going to write that. So 1/3 multiplied by pi multiplied by r squared multiplied by h is equal to 6,174 pi. So we're going to see what can we fill into this formula for the volume of a cone that I've written on the left-hand side. And I've made this equation because it told me that they were equal. So when I'm told that things are equal, I can make an equation, and I'm going to see what can I fill in. So when I look at the cone, it looks like I haven't been given any information. They haven't told me the height, and they haven't told me the radius. But when we have a cone sitting directly on top of this hemisphere, it means that the radius of both of them have to be the same. So the radius of the cone is also going to be 21 centimeters. So I can fill that in for the radius. So 1/3 by pi by 21 squared by, I haven't been told what the height is, so I'm going to leave that as h, is equal to 6,174 pi. I'm going to divide both sides by pi. So we have pi on both sides. So I'm going to divide both sides of this formula by pi, which means that I can cross out those pi's. So I can always do the same thing to both sides of an equals. And that leaves me with 21 squared by 1/3 by h is equal to 6,174. So now I have an equation with just numbers in it. So I'm going to take my calculator. I'm going to multiply 1/3 by 21 squared, which gives me 441 by h is equal to 6,174. And then I'm going to divide both sides by 441. and that's going to solve for h is equal to 42. I need to put in a unit, so h is equal to 42 centimeters, and that's the height of the cone. So I've worked out the height of the cone from the top right down to this piece at the bottom here has a height of 42 centimeters. But that's not what the question asked me. The question asked me to find the total height, and the total height is bolded. So we can see here that it's in bold because they're really emphasizing that's what my question is asking me. So the total height is not just the 42 centimeters that came from the cone. We also need our height of our hemisphere. We don't have anything that's called a height of a hemisphere, but I can see that the height of the hemisphere is from that center point right down to the edge, which means that it's equal to the radius. So the height of the hemisphere here is going to be 21 centimeters, the same as the radius. So when I want to get the total height, I'm going to just add those two pieces together. So I'm going to say the total height is equal to 42 plus 21, which gives me 63 centimeters. So it's really important to just make sure that we're reading every part of a question. So we're told the volumes are equal. We were told that we were looking for the total height, and we just break that question down into pieces like that and solve for the total height. The next question that we're going to look at is a paper 2 question again, and this is 2020 paper 2 question 9. So this question says a rectangular sheet of aluminium is used to make a cylindrical can of radius or centimeters and height 10 centimeters as shown below. The aluminium does not overlap in the finished can. So that means that we're just using this sheet and there's not going to be any piece overlapping when we fold it around. So it says, show that the radius R of the cylinder is 3 centimeters. This can be a little bit hard to see here because what I need to do is draw a net of this diagram, which they have given to me here. But a net is where I take a three-dimensional shape. So they've given me a three-dimensional shape as a cylinder here, and we unfold it to make its net. What would it look like before we put it together? So this diagram here is the net of the cylinder in a rectangle. So we have some extra pieces that are going to be there. So the net of it is this rectangle here with these two circles. They're going to make this cylinder. Now, it's not a perfect net because if it was a perfect net, I should be able to just fold it and get that shape. But I can see that I can't do that here because my two circles are both on the top. I'd need to have one of those circles on the top and one of the circles on the bottom to be a proper net of the cylinder. So they haven't really given me a full net, but we have got what the shape looks like when it's flat, and that's what we're going to work off here. So what we can see is that I can see that when I have this shape, the total height of it over here is 16 centimeters. And I can see that 10 centimeters of it goes into being the height of the cylindrical can. So the height of this cylindrical can here is going to be 10 centimeters, which means that out of this rectangle, we have 6 centimeters left up here. So that 6 centimeters is going to be the total length, the total distance from one side of the circle to the other. And we call that a diameter. So from one side of the circle to the other through the center is my diameter. So I can see here that the diameter of this circle is 6 centimeters. The radius is always half of the diameter. So I'm going to be saying, okay, so the radius here, we had 16 take away 10 to tell us there was 6 centimeters up at the top. That's the diameter of the circle. That makes the lid. And I know that that is going to be divided by 2 to make the radius. So I say 6 divided by 2. And that means that the radius here is going to be 3 centimeters. So when I look at this, it's a very unusual question in that I was given my 2 dimensions and I was given a 3 dimensions, and I had to try and work back and forth between them and see how they would link together. So that tells me that the radius of this cylinder is going to be 3 centimeters. The next part of it says, find the distance y and give your answer correct to the nearest centimeter. So the distance y is this part here on my rectangle. So I can see that this is going to be the circumference of the circle that makes up the lid of that radius of that cylinder and the bottom of that cylinder. So we're going to have a circumference here on the top and on the bottom. So where that circle goes all the way around, and that's going to match the width of this sheet of aluminium that we're going to turn into this can. So now I'm going to have to go to my tables again, because now I'm dealing with a circle. And when I'm dealing with a circle, I'm basically looking for the circumference of this circle. And this is page 8 of my tables. So on page 8, I see a circular disc, and my formula that's given here, this is the one that I want. So the circumference of a circle is the length of a circle, and the formula for the length of a circle is 2 pi r. So I'm going to use that formula, 2 pi r. All I need for it is my radius. So 2 and pi are numbers. So my length is equal to 2 pi r. So 2 multiplied by pi multiplied by my radius, which was 3, and that gives me 6 pi. But the question here says, give your answer correct to the nearest centimeter. So I'm going to have to convert that. In the last question, we were asked in terms of pi. This time we're asked correct to the nearest centimeter. So when I want correct to the nearest centimeter, I'm going to press the SD button on my calculator, and I get an answer of 18.8495. And when I want to round this off to the nearest centimeter, it means I'm not going to have any decimals. So I look at this number here, and that tells me that I'm going to have 19 centimeters. And that was y, was what they called it in our diagram. So we're going to say y is equal to 19 centimeters, and that's correct to the nearest centimeter. And the last part of this question says, find the area in centimeters squared of the waste aluminium after the top, the bottom and side of the cylindrical can have been removed from the rectangular sheet, and give your answer correct to the nearest centimeter squared. So this is why it wasn't a full net that we were being given. We were being given it in this shape because we were going to try and reduce the amount of waste when they were making it. So we have 3 different things that are going to make up our cylinder. We have this rectangular piece down here, which is going to be the body of our cylinder over here. And we have 2 circles, which are going to be the top and bottom of our cylinder over here. So we want to work out the area of all of those, and then we're going to work out the area of the total shape, and to find the waste is the piece that's not used to make up our cylinder. So that's going to be this piece here around the circles at the top, and we'll find that by subtraction. So we have a few things that we need to do in this question. So we're going to find the area of the rectangle. And that formula is length multiplied by width. So I can see that the area of this was 19 was my length and my width was 10. So I can see that 19 is what I worked out for this distance, and we were told that it had a height of 10 for that piece. So 19 times 10 is 190 centimeters squared. I'm then going to work out the area of a circle. And again, I need this formula for my tables. So back here on my tables, page 8, here is my circle. And this time I want my area formula, which says pi r squared. So my formula for a circle is pi r squared. And we know that our radius is 3, so we've worked that out. So I get pi r squared, which is 9 pi. And we have 2 circles. So I'm going to multiply it by 2. So 9 pi multiplied by 2 gives me 18 pi. And that's centimeters squared as well. So the area that's used to make the can is the rectangle plus the circles. And when I add those together, I am going to get an answer of 246.5487 centimeters squared. The total area of the shape, so if we look at the shape again, that's going to be our y, which we worked out was 19, and our total height is 16. So we're going to multiply those two figures to get our total area. So I'll say 16 multiplied by 19, which gives me 304 centimeters squared. So the question was the area of the waste aluminium. So the waste is to subtract. So I'm going to say 304 is the total area minus the 246.5487. And when I subtract those, I'm going to get 57.45. And it says to the nearest centimeter. So the 4 here tells me to leave that alone. So I get 57 centimeters squared waste. So hopefully that has been of some help to you to see some more questions on area and volume and our trapezoidal rule. And like we said on our 30-week countdown on TheMathsTutor.ie, we have a couple of videos there for you to look at. And for everyone, we're giving you access to the trapezoidal rule, so to have another look at that, and the question worked out from 2016 paper 2 on area and volume.